All right, so if you look on page 14 in your packet, you'll see up at the top in the box there are some properties of limits. Now, this is really very easy and straightforward. I know it looks a little overwhelming if you look inside the box. So what I want to do is I just kind of want to go through the questions, and I'll refer back to the box as I go through each question. So I'm going to look at Roman numeral 1 here. Okay, and if you look at Roman numeral 1, you're going to see that they give you three things. So they told you about the limit of g of x as x approaches c, it's 10. H of x, also notice as x approaches c, is 5. And f of x, notice also as x approaches c, is negative 3. When they give you these kinds of conditions, they're always going to be approaching the same letter or the same number. Otherwise, this isn't going to work. Okay, so, and if you look through all, I only have 1 through 6 here, but if you look at all of these, x approaches c, x approaches c, x approaches c, so on, so on, so on. So that's always going to be the same. All right, so we're going to look at the first one here. You notice that there's a 7 here. Now, go up to the box on the top of page 14 and look at the first property there. They said if k is a constant. In this case, let's look back here. Okay, k would be 7 in this case. So if it's a constant, notice that what I can do is I can take this 7, and what it's saying is I can throw it in front here. So by doing that then, what I'm basically going to do is I'm going to be doing 7 times the limit of g of x, okay, and I'm going to just squeeze this in here as x approaches c. All right, so now what I'm going to do is I'm going to go up to the top here, and I'm going to look for the g of x as x approaches c, which is right here. And they tell me that that's 10. So then really, all I need to do is I can say, oh, well, wait a minute, this whole thing is 10. And then I bring down the 7 that's in front of it, and my answer is 70. It's that easy. Okay? All right, so let's look at the second one. So number 2, notice that it says the limit as x approaches c of f of x plus g of x. All right, go to the top of page 14 and look at, in the box, number 2. Okay, so that's exactly what you're seeing on your paper, or I'll point right here on the video, right here. You're seeing the same exact thing, number 2, in the box at the top of page 14. Now go to the right of the equal sign, and what it's saying is you can break each of these two up into 2 separate limits. So basically what I'm going to do is I'm going to look up what the limit as x approaches c is with reference to f of x, which is right here, that's negative 3. So I know that's negative 3 plus, and then I'm going to look for the g of x. And the g of x, if I look right here, is 10. So negative 3 plus 10 is 7, and there's your answer. Okay, let's go to the next one. So let's look at number 3. This one is multiplication. So go to the top of page 14 in the box, look at the third property down. Okay, what you see there to the left of the equal sign is the same as number 3 here. Follow the equal sign over to the right, and you'll see that that means that you can multiply each limit separately. So I know that the limit of f of x as x approaches c is negative 3, and g of x is positive 10. So all I'm going to do here then is I'm going to do negative 3 times 10. So my answer is negative 30. Okay, all right, next one, number 4. Look up at the box at the top of page 14, number 4, there it is. They're using different letters, but it doesn't matter. Okay, at the top of the page in the box there, it says f of x over g of x. That's irrelevant. So we're going to divide each one separately. So let's look at number 4 here on the video. It wants g of x, which if I go and I look will be 10. And h of x, if I go and I look, that's 5. Divide those two, and we get an answer of 2. Okay, get the idea? Really super easy. All right, so number 5, same thing. So we're doing 4 times f of x. So I'm looking at what f of x is, and they say that that's negative 3 minus 6 times h of x, which is 5. So really what I have here is negative 12 minus 30. And negative 12 minus 30 is negative 42. Okay? And then the last one that I'm going to do, because I'm sure you can do 7 and 8 by yourself, is number 6. And let's look at that. So we're going to take f of x, which is negative 3, and they want me to square that value. So then my final answer is going to be 9. Okay? All right. So that gives you a good idea of how these work, really very straightforward. So what I want you to do is I would like you to finish the rest of Roman numeral 1 here. So you're going to do 7 and 8. And then I want you to do Roman numeral 2, all of them, and Roman numeral 3, all of them. So in other words, the rest of the page, all the way up to number 26. Okay? All right, so you should have finished pages 14 and 15 in its entirety. Actually, page 14 in its entirety. All right, so I want to look at page 15. I know that you should have done this last year, but I'm going to kind of review it. I do it a little bit differently maybe than if you had Mrs. Engel or you had Paz, but I'm going to tell you my way. If you know another way to get the right answer, go for it. All right, so with number 6 through 10, basically if you look at all of them, they're asking you to compute a limit, but always as x approaches either positive infinity or negative infinity. Okay, doesn't matter, positive infinity or negative infinity. I always like to start with a picture because I think most people do best when they see a picture. So this is the picture of x plus 7 over 3x plus 5. I totally cheated and I put it in my calculator, which by the way, you're not going to be able to do, but I just want you to see something. So you can see here, here's your picture, and they want to know what's happening as x goes toward negative infinity. So in other words, let's look at this part of the graph, and we notice as we go toward negative infinity, we get further to the left, it approaches an asymptote here. Here's the asymptote, the dotted line here. So it's approaching a value of 1/3. So therefore then, obviously, the answer to this would be 1/3. Okay, now that's wonderful if you have a picture, but you're not going to. So when I see a limit as x approaches either a positive infinity or a negative infinity, I look at what we call end behavior, END, as in like the end of the road. So end behavior basically means that you're going to look at this fraction and you're going to take the highest power in the numerator and the highest power in the denominator. So in other words, this is x to the first and this is x to the 0. So this one is higher. This is x to the first. This is x to the 0, so this one's higher. So what I usually do is I go through and I circle these, and then I just say to myself, oh, I'm going to write it over here. That gives me x over 3x. And then I just think back to basic algebra, and I'm like, oh, see if I can reduce that. Oh, look at that. Bing, bing. Okay, now that's the easiest example, where right away it's going to reduce to a number. Okay? All right, let's look at the next one then. All right, so now let's look at number 7. It is going toward infinity. So again, I'm going to do end behavior. So I look at the numerator. My highest power is an x squared. And I look at the denominator, and that's also an x squared, which is always good. So then basically, I've got 7x squared over 2x squared. And if I do basic algebra, I know that reduces to 7 over 2. And there's your answer. So you don't need to draw a picture. Okay? All right, now number 8 is going to be a little bit different because when I look at the highest power in the numerator and the denominator, okay, I'm going to get x squared over x cubed. Here's a problem because this doesn't reduce to a number. Okay, but think back to your summer assignment and say, oh, what does the graph of 1 over x look like? And this is why I made you memorize it. Well, we know it's like this in the first quadrant, right? And then like that in the third quadrant. Okay. All right, now all you're going to do is you're going to ask yourself, all right, here's my picture. What's happening as x goes toward infinity? Now, this is a positive infinity, so I'm going to go to the right. So watch, I'm going to look here, and as I go to the right, what's happening to the y value? Where is it going? Do you see it's getting lower and lower? So that means that the answer would be 0 because the graph is getting lower and lower as you're going out further to the right, as your x values are getting closer to infinity. Okay? All All right, let's look at number 9. Okay, so we're going to do the same thing again. So number 9, I'm going to take the highest power in the numerator and the highest power in the denominator, and I'm going to reduce that. So that's 7x squared over negative x. So when I reduce that, that's negative 7x. All right, so that's not a number. So I want to draw a picture. Well, I know that negative 7x basically is a negative sloping line, and there's no y-intercept, so that means it goes straight through the origin like that. Okay? All right, now what I'm going to do is I'm going to look here, and it's telling me as x goes toward negative infinity. So in other words, I'm going to the left. So here's my graph. As I go to the left, what happens to the y values? That's what it's asking. So as I go to the left, my y values get larger. So that means the answer is infinity. Okay? All right, now let's look at the last one. So let's look at number 10. So we're going to take the highest power in the numerator and the highest power in the denominator, which would be right here. Now, do you notice that I'm circling the radical as well? It's a funky circle, but so basically what I've got here then is the square root of x cubed over 4x cubed, which is the square root of 1/4, because the x cubes cancel out, right? All right, that's a number. Yay! So all we have to do is just take the square root of 1, which is 1, and the square root of 4, which is 2, and we're done. Okay? So end behavior is going to work whenever your limit is approaching either a positive infinity or a negative infinity. Take the highest power in the numerator and the denominator and see if you can reduce it to a number. Sometimes you can't, but here we could. That's your answer. If it does not reduce to a number, like here, draw a picture of this graph. I'm telling you, what you get 98% of the time will always be something that you should know what the picture looks like. You should know what the graph is. So I know that's a negative sloping line going through the origin, and then all I do is look at this and say, oh, what's happening as I go toward negative infinity? Okay? All right, so now what you're going to then complete is pages 16 through 17. So your homework is to do page 16 and 17. So it's a combo deal. Limits at infinity, and it's also the rules of limits. All right? Good luck. Have a good weekend.